Until now, we see array function commonly used in NumPy. Now we will see NumPy math function. In NumPy math function, these are common math function we use in numerical programming, such like sum of array, mean of array, median of array, standard, mean, and max. So first we will see for one dimension array. Here it is my one dimension array. Here we can see there are so many elements in one dimension array. If we want to see the size of my array, we can see here using dot size. Here we can see there are 12 array. Uh, if we want to print array, we can print array also. Here we can see here it is my array containing 11, 14, 13 up to 22, and the total elements are 12. Here using dot np dot sum np dot sum, we applied this function on array 1D, and we can see the sum of a function the sum of array is 188. How it's showing 188 here, the sum function calculated sum of all elements here, and it giving sum of array is 188. Now this is np dot minimum function we applied, this minimum function will give minimum value from this array. Here we can see the minimum value is 5. Minimum than 5 is not here, so the minimum is 5. Then max value we can calculate. Here np dot max is for max value, and it will give us maximum value from the array. The maximum value is 22. Then we can see here we can see there is another function, that is mean function. What is mean? The mean means it will calculate all the element, it will calculate summation of all elements and divide by total. So here we can see the mean of array element is 15.666. We can use round function and calculate round also. Because of round, it will give the round number of uh, this number, and we can see here 16.0 is the round off. The mean of array element is 16. Then we are calculating medium of array. What is medium? Medium means if this array we put in increasing order, the middle value is our median. Means if we sort this array, if array have even numbers, and then middle one is our median. If for example I have array 4, 2, 3, and 1. This is my array. So what is my median? The median will be we will sort first 1, 2, 3, 4. This is sorted version. Now the values are evens, so we will take these two middle ones value, because in even numbers there are two uh, values are at the medium position, in middle position. So 2 plus 3, and we will divide by 2, then it will give us the medium, that is 2.5. Now what if I have 4, 2, 5, 3, and 1? what this is my array. Then the sorted version is 1 2 3 4 and 5. Now this 3 is my middle value, so medium is 3. This is how we calculate median. Then here it is np.std. It is standard deviation of array. Now how we calculate standard deviation? For calculate standard deviation, first we will calculate mean of this value, mean of this array. After mean, we will subtract from each element. The mean we will subtract mean value from 4, then from 2, then from 5, like this, and we will sum all the elements and divide by total numbers. Here total number is 5. So this will give a standard deviation. Standard deviation means how data is s- uh, how data is separated. Suppose here 1, here it is 2, here it is 3, 4 and 5. If standard deviation is here, then we can see this much area array have covered, and this is our standard deviation. So we can see here, using Numpy math functions, we can calculate sum, minimum, max, mean, median and standard. Now we will see for 2D array. Here I am creating 2D array using reshape function. Uh, Here already I created one dimension array. Now using reshape, I am having 3 rows and 4 columns. And I am creating here my 2 dimension array. Here we can see the sum of array is the same as above, because number of elements are this much only. Here also the number of elements are 12. These same elements are here. The elements didn't change. We change only dimension. So we can see here the sum of array is 188. Now the we can see we calculate sum of array, but if we want to calculate sum of our columns, means 11 plus 21 plus 5, then 14 plus 18 plus 17, this also can possible. Here in some function we are using axis equal to 0. We already see axis 0, it represent column in 2 dimension. So here using axis equal to 0, it will calculate sum of columns. So here we can see the sum of 11 21 5 is given here, that is 35. Then sum of 14 18 17, that is here, that is 49. Sum of 13 19 16 is 48. So here using axis equal to 0, we calculate sum of columns. Now similarly, using axis equal to 1, we will calculate sum of rows. Here we can see it giving sum of rows. Here we can see sum of 11 14 13 12 is 50. Sum of 21 18 19 20 is 78, and sum of 5 17 16 22 is 16. This is how we calculate the sum of each row. Now we will see the minimum value in array. So we take same elements from 1D array. So again my minimum value is 5, my maximum value is 22. Mean is also same, because we calculating mean in same way. We taking every element, summation of every elements, and dividing by 12 with total number of elements. Then medium is also same, and standard deviation is also same. Then we will see how we will apply this function on 3D array. In 3D array, again using previous array, I am creating 3 dimension array. Here we can see there are 3 depths, 2 rows and 2 columns. Now you can see here it is my three three dimension array. Here we can see on the front side first depth contains 11, 14 and 13, 12. Then behind this depth is here 20, 21, 18, 19, 20. Then behind this 5, 17, 16 and 22 is there. If we want to visualize, we can visualize here. I will show. Here we can see 11, 14, 13, 12 is front side. Here it is 11. Here it is 14. Here it is 13 and here it is 12. Behind that we can see 21, 18, 19, 20 is there. Here it is 20 behind 11. Here it is 19 behind 14. Behind 14 there is 18 and 19, 20. Here behind 14 is 18. Then behind 13 it is 19 and here it is 20. Now we will see 15, 5, 17, 16, 22. Here it is 5. Here it is 16. Sorry. Here it is 17. Then here behind 14 it is, behind 19 it is 16 and then 22. Here we can see the sum of array didn't change because there are same elements from previous array. Now we will see here in 3D axis 0 is representing depth. So the sum we using axis equal to 0 we calculate sum of depth. We will calculate sum of depth. Here we can see 11, 21 and 5 are in same dimension. Here then here it is front side, here it is back side of the front side and then here it is last side. So we are calculating sum of depth. So the how it will calculate, here we can see 11 plus 29 plus 5 will be given here as a 37, we can see here. Then 14 plus 18 plus 17 are in same align, so it will be 49, it will be given here same. 13 then 19 and behind there is a 16. 13, 19, 16 we can see here also. So this will, the sum is given here 48. Now 12, 20, 22. Here we can see 12, 20 and 22 is here. So the sum of there is 54. Now if we put axis equal to 1, then it will give the sum column wise. Now we can see in same column 11 and 13 are in the same column. Here also we can see 11 and 30 are in same column. So 11 plus 13 is 24 is given here. Then 14 plus 12 is given here, 26. Then 13, then 21 plus 19 is given here. Same 18 plus 20 is given here, and this is how the column wise summation is happening. Now we will say access equal to 2 will give the row wise summation. The row wise means 11 plus 14. Here we can see 11 plus 14. It will given here 25. Then 13 plus 12 is again 25. It will be given here. Then 21 plus 18 is here given 39. Then 19 plus 20 is also 39. It will be here. This is how we calculate summation of 3D array, depth wise, then column wise, then row wise. Now, if we see here, minimum value will be same as before, maximum value is also same, then mean also same, medium also is the same, and standard deviation is also same. This is how we can calculate sum, uh, then minimum value, maximum value, mean value, medium value, and standard value of array.